let's have a look at the binomial theorem. So, a binomial expansion. Well, binomial, as we know, something with two terms. So, that's a binomial. A binomial expansion is then when we get that thing with two terms and expand it. The most simplest one is probably not the one you're thinking of. You probably would have thought power of 1 is the most simplest, but actually the most simplest is 1 plus x to the power of 0, which is just 1. And then to the power of 1, yes, I've deliberately written in the coefficient of x there so we can see the pattern that emerges. 1 plus x squared, 1 plus 2x plus 1x squared. And we can keep going. So 1 plus x cubed, if we wanted to create that one. There we go, 1 plus 3x squared plus x cubed. And then if we want 1 plus x to the power of 4, we can multiply that by 1 plus x. 1 plus 4x plus 6x squared plus 4x cubed plus x4. And we notice a pattern is emerging. Blaise Pascal, the pattern known as Pascals Triangle. He wasn't actually the first, but I think I mentioned this before. He wasn't actually the first person to see this pattern. It's been known for thousands of years before Pascal. And the reason Pascal gets all the credit is because of the relationships he discovered within the triangle. So it starts with 1. There's 1, 1. Ooh, 1, 2, 1. Ooh, it gets very exciting. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. That's a nice row. I think I like that one. 1, 7, 21, 35, 35, 21, 7. Oh, here comes 8. Ah, lovely. 9. That's a beauty. You got to like that one. Now the best of them all. Oh, you got to admit, 10's fantastic. So look at 10. How good is that? Look at the numbers. Yes, 120, then 210, so the same digits just play around, and then we get into the middle, and we know the row's symmetric, but the middle term's also symmetric. Oh, 252. That is a fantastic row, you've got to admit. That's very exciting. You know, I'm sure you have your own personal favourite. Alright, so we can use that to expand out. So 1 plus 2x on 3 to the power of 7. Here we go. Powers of 1 start at 7, go down by 1. Powers of 2x on 3 starts at 0, goes up by 1. The two powers always add up to be the power of the expression, so in this case 7. And then we add in the coefficients into each term. So each term gets multiplied by its respective coefficient. So we tidy that up, and voila! 1 plus 2x on 3, all to the power of 7. So knowledge of that triangle, knowledge of those coefficients certainly saves us a lot of time. Yes, it's still a fair bit of work there, but we don't have to expand out and expand out and expand out and expand out. Here's where it's useful. And I'm sure you've experienced this yourself. When, you know, you've been out, I don't know, in the shopping centre or something like that, and someone's come up to you and said, look, excuse me, I don't have a calculator on me, but do you know what 0.998 to the power of 10 is? Just 8 decimal places though, I don't even need 8 decimal. I'm sure it's happened to you. Well, you wouldn't want to be embarrassed, but hey, because we could use 1 minus x to the power of 10, 10 being that fantastic row. So 1 minus x to the power of 10, there's the expansion. But I'm going to rewrite it as 0.998, which would be 1 minus 0.002. But they only want it to 8 decimal places. So 0.002, once I get to the power of 4, is 0 to 8 decimal places. So I don't need the terms after the power of 3. I only have to work out those. And when you think about that, that's quite simple. Because you're just saying, well, for the last term, well, 2 cubed is 8, and then the appropriate number of zeros, multiplied by 120, and so on. And so you could then turn to that person in the shopping centre and say, oh yes, well actually it's 0.98017904. And they'll say, thank you very much. And everyone will be happy. See the power of mathematics in the real world. If I have to find the coefficients Okay, find the coefficient of x squared. So expand out the second one. Now, I'm not going to bother expanding each of these individual terms because I'm only interested in the one that ends up with x squared. So the 2 would be multiplied by this term, 6 times 4 squared times 5x squared. So I know that term is important. The negative 3x would then get multiplied by the second term there. So really they're the only 2 terms I'm interested in. So if we expand those ones out, and it's just the coefficient, so I'm not worrying about the x's, but there's our answer, 2 times 6 times 4 squared times 5 squared minus 3 times 4 times 4 cubed times 5, which works out to be 960. 5A.